Hello my Linians, this is teacher Sarah, and today we are going to discuss zeros of the functions, intercepts, asymptotes, and problem solving involving rational functions, equations, and inequalities. This video tutorial is based from your learning activity sheets in General Mathematics Quarter 1, Week 3. So bring out your learning activity sheets and turn your learner's module to pages 44 to 56. Before the lesson, let us have some warm-up questions. I have some questions for you to answer. Our learning targets are: determine the intercepts, zeros, and asymptotes of rational functions. Solve problems involving rational functions, equations, and inequalities. Which of the following is a factor of x squared minus x minus 20? What do you think is the answer? Timers start now. Very good. The correct answer is letter A. Quantity x minus 5 times quantity x plus 4. Which of the following is a factor of x squared minus 16? What is the correct answer? Timers start now. Okay, the correct answer is letter C. Quantity x minus 4 times quantity x plus 4. So from your warm-up, so you recall your lesson on how to factor polynomials, since this is a prerequisite of our topic for today. Okay class, be ready in our session. Okay, the zeros of rational functions. In the function n over d, where n is the numerator and d is the denominator, the denominator must not be equal to 0 since division by 0 is undefined. Thus, 12 over 0, 7 over 0, and 0 over 0 are all undefined. However, in the same fraction, numerator over denominator, if n equals 0 and d not equal to 0, then the fraction is equal to 0. For example, 0 over 12, 0 over 7, and 0 over 6 are all equal to 0. In general, when dealing with rational functions, whatever value of x that will make the numerator 0 without simultaneously making the denominator equal to 0 will be a zero of the said rational function. The zeros of the function is the value for which f of x is 0. In symbol, f of x equals 0. For values for which f of x is 0, in symbol, f of x equals 0 or f of x equals y. Let's have some example. F of x equals 3x squared plus x minus 10. By factoring, you factor 3x squared plus x minus 0. And the factors are quantity 3x minus 5 multiplied by quantity x minus 2. And then equate its factor to 0. So 0 equals quantity 3x minus 5 times quantity x minus 2. Then, if you equate its factor to 0, then you solve for the value of x. So, x equals 5 over 3 and x equals 2. So there are two zeros, such as 5/3 and 2. Another example, f of x equals x minus 3 over x plus 3. Since 0/1 equals 0, so your 0/1 should be replaced to f of x, or your f of x equals y. So 0/1 equals x minus 3 over x plus 3. Then by cross multiplication, we have 1 multiplied by quantity x minus 3 equals 0 multiplied by quantity x minus 3. And then to simplify, so we have x minus 3 equals 0. And then by applying addition property of equality, so you may add positive 3 on both sides of the equation so that x is equal to 3. So we have alternative solution for that example. So we are going to equate our numerator to 0 and then you solve for x. Our numerator is quantity x minus 3. Then equate to 0, therefore x equals 3. Therefore, the zeros of the function is 3. Another, we have g of x equals x squared minus x minus 6 over x squared minus 9. So, you are going to factor both the numerator and the denominator if factorable. In our example, x squared minus x minus 6 and x squared minus 9 are factorable. So, factors of x squared minus x minus 6 is quantity x minus 3 times quantity x plus 2. And the factor of the denominator, x squared minus 9, so that is factoring of the difference of the square. So, the factors should be equal to quantity x minus 3 times quantity x plus 3, or the sum and difference of their square. So, observe our numerator and denominator. So, numerator and denominator with the same factor should be cancelled. So, we have quantity x minus 3 in the numerator, and it is also the same in the denominator. So, you cancel them. Then, you are going to equate the numerator x plus 2 to 0. Then, solve for x by applying the addition property of equality. You add negative 2 on both sides, and then you cancel positive 2 plus negative 2 becomes 0. Then we have 0 minus 2. Therefore, x equals negative 2. So, therefore, the zeros of the function in that example is negative 2. Then, what about the intercepts? So, there are two types of intercepts, the x and the y. Intercepts are x or y coordinates of the point at which a graph crosses the x-axis or the y-axis respectively. To find the y-intercept, you substitute 0 for x and solve for y, or f of x. And to find the x-intercept, substitute 0 for y and then solve for x. So let's have an example. For x-intercept, as stated, to solve for the value of x-intercept, you set f of x equal to 0 or y equals 0. So in our example, f of x equals 3x squared plus x minus 10. So you set f of x to 0 equals 3x squared plus x minus 10. Then by factoring, since the left side is factorable, so we have a factors of quantity 3x minus 5 times quantity x minus 2. Then you equate its factor to 0. So we have 3x minus 5 equals 0. Therefore, x equals 5 over 3. X minus 2 equals 0. Therefore, x equals positive 2. So, we have two values for x, such as 5 over 3 and 2, and they are called the x-intercepts. For y-intercept, you set x to 0. Our example, we have g of x equals x squared minus x minus 6 divided by x squared minus 9. Both numerator and denominator are factorable. So you factor both numerator and denominator, then simplify. So numerator, we have a factors of quantity x plus 2 and quantity x minus 3, while our denominator, we have quantity x minus 3 times quantity x plus 3, or the sum and difference of 2 squared. Then, in the numerator and denominator, they have the same factor, so you may cancel them. So the remaining quantity y equals x plus 2 all over x plus 3. So to give a value for x, in finding the y-intercept, you set x to 0. Therefore, y equals 0 plus 2 over 0 plus 3, or y equals 2/3. So therefore, the y-intercept is 2/3. For x-intercept, you set y equals 0. So example, g of x equals x squared minus x minus 6 divided by x squared minus 9. So your g of x is equal to y. So y equals quantity x plus 2 times quantity x minus 3 over quantity x minus 3 times quantity x plus 3. These are the factors of the numerator and denominators. So, where g of x is equal to y and y is equal to 0, so you replace 0 to y. So, it becomes 0 equals quantity x plus 2 times quantity x minus 3 divided by quantity x minus 3 times quantity x plus 3. So, numerator and denominators with the same factor is cancelled. So, since 0 over 1 equals 0, so you replace 0 by 0 over 1, then equals the remaining quantity on the left side, x plus 2 over x plus 3. Then, by cross multiplication process, you multiply 1 times quantity x plus 2 equals 0 times quantity x plus 3, and then x plus 2 equals 0, then solve for x becomes negative 2. So therefore, the x-intercept is negative 2. Next, let's move to asymptotes. There are types of asymptotes. So these are the vertical asymptotes represented by VA. Then the horizontal asymptote represented by a symbol HA. So a rational function is a function that can be written as f of x equals p of x over q of x, where p of x and q of x are polynomial function and q of x not equal to 0. Vertical asymptote is x equals a, where a represent real numbers of q of x. Illustrative examples. So you find the vertical asymptote of q of x equals x squared minus 16. So you find the factor of the given q of x. Since it is factorable, the factors we have quantity x plus 4 times quantity x minus 4, or the sum and difference of their square, then equate to 0. Then x plus 4 equal to 0 and x minus 4 equals 0, or x equals negative 4 and x equals positive 4. So the zeros are negative 4 and 4, thus the vertical asymptote are x equals negative 4 and x equals positive 4. Okay, another example, f of x equals x minus 1 over x squared plus 5x plus 6. So, in finding the vertical asymptote, first is to factor, then x minus 1, not necessary to factor while the denominator is factorable. So, factors are, we have quantity x plus 2 times quantity x plus 3. Then, you equate the denominator, the factors in the denominator equate to 0, and then solve for the value of x. So, we have x plus 2 equals 0 and x plus 3 equals 0. Therefore, value of x equals negative 2 and x equals negative 3. So therefore, those value of x are the zeros and they are also the vertical asymptote. So the vertical asymptote are x equals negative 2 and x equals. Okay. Another, we have f of x equals x squared plus 3x minus 10 over x squared minus 4. So, the numerator and denominator are factorable. So, the first step is to factor both numerator and denominator, and the factors are, we have quantity x minus 2 times quantity x plus 5 for the factors of the numerator, and for the factors of the denominator, since this is a perfect square binomial, so the factors are the sum and difference of the square. Then you cancel the factors that are the same in numerator and denominator. So we have the remaining quantity. We have quantity x plus 5 over quantity x plus 2. And then the second step in finding the vertical asymptote is to equate the denominator to 0. Our denominator is x plus 2 equate to 0. That becomes x plus 2 equals 0. Then solve for the value of x. So, our x equals negative 2. Therefore, the vertical asymptote is x equals negative 2. So, note that a vertical asymptote does not exist at x equals 2, as it is a value that also makes the numerator 0. A hole exists in the graph at x equals 2. So, if you are going to plot that in the graph or in a Cartesian plane, so if x equals 2, it does not exist, meaning you are going to put a hole. So, meaning a hole exists in the graph at x equals 2. For f of x equals 4 over x squared plus 1, again, to find the vertical asymptote, you are going to factor the given. But since in our example, there is no quantity which is factorable, so second step is to equate or set the denominator to 0. Our denominator is x squared plus 1, then equate to 0, then solve for the value of x. So our x squared equals negative 1, then solve for the value of x. X equals positive negative square root of negative 1. So in our example, there is no vertical asymptote, means no real solution, because square root of negative 1 is imaginary number, or it is represented by the symbol I. Okay, the second type of asymptote, we have the horizontal asymptote. Okay, a rational function f of x is a function that can be written as f of x equals p of x over q of x, where p of x and q of x are polynomial functions and q of x not equal to 0. The horizontal asymptote is determined by looking on the degree of p of x and q of x. So, you'll recall your lesson or your learnings in finding the degree of polynomial. So, degree refer to the exponent. So, in finding the horizontal asymptote, you can determine it by just looking on the degree of the polynomials p of x and q of x. So, there are three cases that you need to consider. First, if the degree of p of x is less than the degree of q of x, the horizontal asymptote is y equals 0. Second one, if the degree of p of x is equal to the degree of q of x, then the horizontal asymptote is y equals the leading coefficient of p of x over the leading coefficient of q of x. So, you are going to identify the leading coefficient of the numerator or the p of x and the leading coefficient of the denominator or the q of x. Then, for the other case, if the degree of p of x is greater than the degree of q of x, then there is no horizontal asymptote. Examples. Find the horizontal asymptote of the given rational function. F of x equals negative 2x over x squared minus 4. So, the degree of p of x is equal to 1 and the degree of q of x is 2. So, look in our example. The degree refers to the exponent. For p of x, the exponent is 1. So, it is not indicated. If it is equal to 1 as its exponent, so in mathematics or in algebra, no need to indicate 1 as its exponent. And then for the q of x, the degree is 2 since the exponent of x is 2. So therefore, if the degree of p of x is less than the degree of q of x, so the horizontal asymptote is equal to 0. Another example, f of x equals 3x plus 1 over 2x minus 1. So, degree of p of x is 1. That is 3x exponent is 1. Then, denominator, we have 2x minus 1. The degree is also equal to 1. So, therefore, the degree of p of x and the degree of q of x are equal. So, the horizontal asymptote is the ratio of the leading coefficient of p of x and the q of x. So, the leading coefficient of p of x is 3, while the leading coefficient of q of x is 2. Then, you are going to get the ratio, and that will be the horizontal asymptote. So, in letter B, the horizontal asymptote is equal to 3 over 2. Then, for the third example, f of x equals 3x squared plus 1 over 2x minus 1. So, look at the degree. The degree of the numerator is in the second degree, or that is your p of x, and the degree of the denominator is 1. So, compare their degree. So, since the degree of p of x is greater than the degree of q of x, therefore, there is no horizontal asymptote. Okay, then let's proceed to solving problems involving rational equations and inequalities. So, for example, in an inter-barangay basketball league, the team from Barangay Mayapyap has won 12 out of 25 games, a winning percentage of 48%. How many games should they win in a row to improve their win percentage to 60%? So, solution. Let x represent the number of games that they need to win to raise their percentage to 60%. The team has already won 12 out of the 25 games. If they win x games in a row to increase their percentage to 60%, then they would have played 12 plus x games out of their 25 plus x games. The equation is 12 plus x over 25 plus x equals 0.60. Then multiply 25 plus x to both sides of the equation and solve the resulting equation. So, we have 12 plus x over 25 plus x equals 0.60. Then, applying your knowledge in algebra, so you are going to multiply, or you apply the cross multiplication process. We have 12 plus x equals quantity 25 plus x times 0.60. Then simplify. Then finally, x equals 7.5. So therefore, Barangay Mayapyap needs to win 8 games in a row to raise their winning percentage to 60%. Example number 2. A box with a square base is to have a volume of 8 cubic meters. Let x be the length of the side of the square base and h be the height of the box. What are the possible measurements of a side of the square base if the height should be longer than a side of the square base? So, solution. The volume of a rectangular box is the product of its width, length, and height. Since the base of the box is square, its width and length are equal. So the variable x is the length of a side of the box, while h is its height. The equation relating h and x is b equals x squared h. Expressing h in terms of x, we obtain h equals 8 over x squared. Since the height is greater than the width, h greater than x, and our inequality is 8 over x squared greater than x. To solve this inequality, we begin by rewriting it with 0 on one side. So we have 8 over x squared minus x greater than 0. And then you make the left side a single rational inequality. So we have to find the LCD and then simplify. So our LCD is x squared. So x squared divided by x squared is 1 multiplied by 8. That is 8. Then minus x squared divided by 1 multiplied by x is x cubed greater than 0. So we have quantity 2 minus x multiplied by quantity x squared plus 2x plus 4. So this is a factor of cube. Factoring a cube, 8 minus x to the third power. So you get the cube of 8, and that is 2. Then cube of x, we have x, and the sum is depending on the sign, and that is negative depending the sign of the cube, difference of cube. So we have quantity 2 minus x. Then the other factor is square the x plus product of the first and the second term, 2x plus square of the first term over x to the second power greater than 0. Okay, B. The rational expression will be 0 for x equals 2 and undefined for x equals 0. Then, you plot on a number line and use hollow circle since these values are not part of the solution. So, you recall your lesson in solving rational inequality. So, we tackled that already in your previous. Okay, look in the given number line. You locate 0 and 2 and you indicate it by a hollow circle since 0 and 2 are not included as the solution set. And then next is to construct a table of sign to determine the sign of the function in its interval determined by 0 and 2. And note that x squared plus 2x plus 4 is positive for any real values of x. So these are the interval, the test points, and these are the factors. And these are the sign, the resulting sign of the values for its interval and for its test point. So since the rational expression is positive in the interval 0 less than x less than 2, this is the solution set of the inequality. We reject the interval x less than 0 even if the expression is positive here, since we only consider positive values of x for this problem. So therefore, the height of the box should be less than 2 meters. At this point, turn your activity sheet to enrichment part. For enrichment activity 1, you identify the zeros, x and y intercepts of the following, then write your answer on your answer sheet. So remember, Do not write anything on this activity sheet. Write your answer on a separate long bond paper. For enrichment activity 2, you identify the vertical and horizontal asymptotes of the following rational function. Show your solution to justify your answer, then write your answer on your answer sheet. For enrichment activity 3, you solve the following problems. Show your solution and write your answer on your answer sheet. And for wrap-up activity, you are also required to answer the following questions so that you can get additional points. I hope you learned something today. If you have questions or clarifications regarding the topic we discussed, feel free to contact your subject teacher through text, call, or post your questions on your official Facebook group or Thank you for watching. Don't forget to like and subscribe. Bye-bye.